Wow, this baby doesn't look too bad. What did it take to bring it back to this kind of condition? Stand by for part 2 of the Lafayette HA700 Dream Receiver. So I'm sure I don't have to tell you guys about the magic of Neverdal. As you can see, it can really shine up knobs. Now this oddball knob here is not an original. I was using that as the band spread knob. I put a fanciful large knob on the band spread knob, as a lot of us did in the day, to get that extra band spread with a big knob. But I am looking for the original knob on eBay. I'll eventually find one at a flea market that will match the other ones. And you can see that the Neverdal has really shined up the knobs nicely. So you guys are wondering why I don't just stick the tubes in this thing and fire it up. Well, let's just say consistency. In my videos, I like to show off this little cheap tube tester from the 60s. It's pretty cute. It's this EMC. Has a little book that goes with it, and I want to test the tubes. Sometimes you find out it's the tube tester you're actually testing and not the tubes. But one thing I noticed as we go down the line here, and we have the RF amplifier and the two IFs, are 6BA6. But the 6BL8 frequency changer, which is a mixer and an oscillator, has been substituted by a 6GH8, which is similar to a 6U8. So I had to consult with my RCA receiving tube manual. And of course, when I look up the 6BL8, it says it's a 9DC pinout. But when I go to the 6GH8, it says 9AE. And this one is definitely an RF tube, but the 6GH8, it says, is mostly used for multivibrator type horizontal deflection circuits. Now, this technician, engineer, 13-year-old, whatever, has made a tube substitution, and I can't see any different in the pinout. So there's something confusing about this. Why would they have two different pinouts for essentially the same base diagram? But maybe it has something to do with the structure inside the glass envelope. But I will indeed look for a 6BL8 in my tube stock, and I will test it against this 6GH8. It'd be interesting to see how both of them perform in the receiver. So the first Matsushita 6BA6 tube is testing good. So here's the second one. Just about identical. So I actually found a 6BL8 in my junk box. It's a pretty fancy one too. This is Amperex. It's got a little tube here that's, you know, he's expelling all kinds of noise. Made in France by the Amperex company. It's an ECF80 6BL8. That's a pretty fancy tube right there. And both sections are good on the 6BL8 that I found at Amperex. So a lot of times I like to make fun when I look at a receiver and see some soldering that maybe is not quite up to you know, mil-spec or NASA standards. I'll make a comment like, you know, the bigger the blob, the better the job, that kind of thing. And I did make fun of some of the connections, especially around that transformer incident, the repair technician or the excellent 13-year-old engineer that did the work. Again, I have not mounted the proper filter capacitors yet. We reformed this capacitor somewhat, and we're just going to fire it up with the Variac as is. Now, the tubes have 3 shields that are required. One was missing in the set, but, you know, in the junk box I've got some of these old shields. These are actually quite effective shields. It's a spring, kind of a spring brass with some chrome or some tin plating on there. And when you slide this over the tube, you get a ground that goes all the way down and captures the side of that spring shield, and it really makes a good contact. So these, you may laugh at these as being really cheap or something, but they're actually very excellent tube shields. So let me try to put the one on this one. That's it. You just stick it on there and it basically shields the tube. So there's only 3 tubes that have shields. Let's put those in here. And these are very sharp, and they will bite, so be careful when you're putting these shields on. They can bite. Okay, what about this last one? Where is it? It's over here. Yeah, the converter tube gets one too, so let's get that on there. And there we go. Okay, everything is all shielded. All the tubes are in. I've attached a speaker. This is really the moment of truth, right? So let's turn it on, make sure it's on. It's in the AM mode. And everything's turning freely. I've got this up at the set point. Let's bring this variac up to about 50%. Let that warm up a little bit. Let's bring it up even more. Okay, that should be full blast right there. I can see dial lights. Let's see if something. You're always looking for smoke at this point and so on. Oh, I hear hum. Hum is good, right? That just reinforces the idea that we do need to replace the capacitors. But we had high voltage, so the oscillator should come on, and we should have some kind of signals here. Let's see what we got. We should have the audio gain up full, RF gain. Bring that up. Ooh, I hear something.
35 feet. Yeah, I love it. Yeah, I mean, I've already said a few times on the show, I really think that the Lions have a chance to be.
So when you cannot find the exact replacement cap, or you don't want to pay the money for it, you can make up an assembly of 3 capacitors like this. This is all fitting on one terminal strip. 3 of them are grounded together, and then there are 3 hot leads that will go down through the chassis. Now, if this was a showpiece, you probably would get the correct capacitor, or you'd bury these underneath the chassis where you can't see them. I am fairly lazy, and I'm going to simply mount it using this mounting hole that's conveniently on top, and just put the original screw in there. Double up the ground, make sure it's a solid ground wire to chassis, soldered to the chassis. I'm not just going to depend on that. And I'm going to disconnect the leads from the original capacitor. Don't just parallel them on there. Disconnect the leads. Keep this one for show. And bring leads up to connect to the 3 capacitors. Oh, also I got something here I want to show off. These are tube extenders. Let's say we were having some problems and we needed to troubleshoot these miniature tubes. These are extenders that allow you to put your meter on the outside of the tube. And these were really popular back in the TV servicing days. So the first, turn this down, first thing that we notice with the receiver is we have almost no hum at all. So big improvement by using the 3 capacitors instead of the original. I've completely disconnected the original. No more hum. Now, the receiver doesn't seem super sensitive. It's picking up all kinds of stations, but it's not fully tuned, that's for sure. Well, I found out what the audio problem was, the low gain, and the problem was me I'd replaced a resistor, and it turned out that I'd read the resistor wrong because it was one of those charred guys that was covered with the goop. Somehow I interpreted a 470K resistor, a plate resistor, as a 180 ohm resistor. And when you put a 180 ohm resistor in the plate of a voltage amplifier, it turns it into a cathode follower, basically. And that was the symptom. The low gain was just, the plate just had such a low impedance, it had a very low gain. Most of the gain was going into the cathode instead of the plate circuit. So now that I've replaced the 470K resistor on the first stage, the voltage amp stage, which is half of the 6BM8 audio output tube, we have a lot more gain. So let's hook everything up again. I just took the coupling cap off the volume pot. It's a really easy way to inject audio into the amplifier. So troubleshooting of the amplifier completed. Let's hook the receiver back up. So when you're attempting to do an alignment on this receiver, just remember that this thing hasn't been touched for many, many years. Trio, the company that made the receiver, actually manufactured the trimmers. They're very nicely done. They're ceramic trimmers with mica insulator, but they're a little bit crude to adjust. And notice there's this white paint on everything. The white lacquer paint is what they used after alignment as kind of a glue for all the settings. You really need to loosen every single control up before you put the bottom cover on. And that's easiest done by just heating it with the tip of your soldering iron on each control. Break that loose slowly. You might need to use a little bit of some kind of solvent there to get the paint loose. If you do not, you will break the ends off the adjustable inductors and capacitors that are piston style because the metal is not great, and you just won't have enough force to break through that paint. Best to do it first, get everything loosened up. Also, there's a trimmer hidden back here. You can't even see it. And when you put the cover on, those holes are oversized on the cover that goes on the bottom that they say you have to have in place. You can't even see this trimmer here. This is one of your very first adjustments, and you can't even find it. So make sure you make room to get down into that trimmer. You might even have to do that one trimmer with the cover off. Just some tips on the alignment. It can be very easy or it can be very difficult. Like all of these style receivers, typically you adjust the low end of the band first, typically with an inductor, and then you adjust the high end of the band, typically with a capacitor. And that's how you spread the band to make it fit the slide rule dial perfectly. So I'm adjusting the 455 kilohertz IF. Again, using the RMS voltmeter. I do have an 8 ohm load, and I'm injecting using a scope probe, which works very well to inject into the IF. Okay, so now we're doing the RF portion. The signal generator output is going through a pad into the antenna terminal. Basically, just using a 6 dB pad coming out of the generator into the receiver, just to establish 50 ohms at that point. The generator normally has a 50 ohm output, but if you have a lower quality generator, it's always nice to establish 50 ohms with a pad. Then you need to set the generator for 600 kilohertz. I'm pretty close here. Okay, get that set up to 600. Okay. And then you tune the front of the receiver. Okay, and I'll bring this back so you can see it. The front of the receiver is tuned to 600, and the band spread is over here at the set here mark. Connecting to the 4 ohm output port on the output of the receiver, and that of course we have an 8 ohm speaker attached. The 8 ohm speaker represents an acceptable load. You could use a resistor as well. Going into the AC voltmeter. So we set the controls on the front. This is the AM mode. RF IF gain is full. Trimmer is in the center. We want to set the audio to 3/4, not maximum, 3/4, so that we get a good reading on the meter. Now we're just setting the oscillator, so we have to find that difficult trimmer. Okay, close enough. Now you're going to be going back and forth with these adjustments, so don't go too crazy on the first setting. Then they take you to the top end of the band and you adjust the trimmer, and you go back and forth. Then you adjust the antenna, and you work your way down through the whole bands. And don't be afraid to repeat the process over again till you get the band spread just perfect on this. Okay, here's a secret alignment trick that you might not have heard of. Now when you're doing alignment and you have a band such as band 3, where we have set points at 2 megahertz and 4 megahertz, those two frequencies are harmonically related. So when I set the signal generator up for 2 megahertz, if I turn the gain up and overload the mixer a little bit, I should be able to get a harmonic response out of the generator at 4 megahertz. That means I don't have to go back and forth tuning the generator. I can do my set point at 2, whip the dial up to 4, and do my set point without having to change the generator. Let's try it. So let's go down to 2 megahertz. There it is, right? Down here at 2 megahertz. Now I'm going to increase the gain of the generator a little bit. I'm going to go up here to my second set point, which is 4 megahertz. There it is, at 4 megahertz. That saves a lot of time when you're aligning to not have to adjust the generator twice.
For Community Day, you have a nice day, 73.
So I've got an issue. I had one band that would not align. The fourth band, the 4.8 to 14.6. I couldn't get it to align properly. And I've got another symptom. 20 meters is supposed to be upper sideband, but the BFO says lower sideband. Think about it. What have I done wrong? The answer is I've got the local oscillator on the wrong side of the carrier. So instead of high side injection, we're talking about low side. So I've got to realign it on that band and move the LO to the high side so that we get the proper upper side band. So that's how that got troubleshot. Sure enough, 1354, low side injection for 14 megahertz. So let's see if we're on the right sideband now.
He's got an email. So do you, and you, and you, and you.
Excellent. So it's on the upper sideband side now. Calibration point is correct.
He sent me an email saying you're 40 over 9, Joe.
We are now working on the right sideband.
spiritual and physical.
From their website, legalexchangeshow.com.
Freezer and refrigerator. Use plastic bags filled with ice or water if you have enough time to freeze it in your freezer. Use block ice if possible in the refrigerator. And when the ice melts, you can drink the water.
전파 라디오 9390kHz와 12195kHz, 12435kHz에서 들으실 수 있습니다.
Drinking a dilute for these Russian soldiers who disobey Russian orders.
Yeah, they should, otherwise they have nowhere to go. They cannot go to.
PS590SG, that's putting out about 25 watts into a Kenwood TL922 Alpha. Okay, very good, very good. Yeah, and the antenna, what are you using for an antenna? Homemade dipole for 80 meters. Alrighty, that's nice. Very nice. Yeah, well, I have
A non-resonant. It just was overwhelmed, you know.
This is 75 meters in the morning. I don't have the RF gain fully
I
up.
still have it running. Oh, I get this one.
Basically, when you're doing single sideband detection, you want to back the IF gain off, set the gain with the audio control. That gives you the best dynamic range.
Armchair copy, Nate. And you're 20 over 9 there on your peaks, over.
All right, sounds great. All right, I better get on with it here before I get in trouble, Leroy. Have a great day.
Okay, you too. Take care. 73 and 1 FTN will be clear.
Okay, weather copy with Kilo Delta 2, Alpha Oscar Mike. Did I get any of that right?
You came close there, Nate. This is Kilo Delta 2.
Oscar Alpha Mike. And I'm over here in Oakfield, New York. E-car's number 20907. And we're at 50 degrees right now, heading towards 60 according to the weather report. Cloudy skies. It looks like we're going to have some...
Ham radio since 1964, so I go back a little bit, and still moving and shaking here. Anyway. Much coffee, so I'll be potting all day if I drink 2 cups of coffee. Take care, Cliff. Have a good one. K6KZ8N. KC4RUE. I'm heading upstairs. Bye-bye.
You can literally see the flakes of skin just kind of fly off of it, so you got to hydrate a lot. And not with the vino, not with the wine. You got to drink lots of H2O. But anyway, yeah, maybe we'll see you next June, a year from now, in Friedrichshafen. We love going there. Another year, and hopefully everyone will stay safe. Frank, have a good evening, my friend, and we'll see you again. EA3CC W0RAC 73.
Roger, Rick. I'll pass along your best to all the crew here. And hopefully next year I will be able to be here and enjoy the new goodies and the new stuff that is coming every single year. See you soon, Rick. God bless. Happy Easter. EA3 Charlie. Bye for now.
Bye-bye, Frank. 73.
Thank you.
Rick, November 4, Uniform Victor Charlie.
Who's the breaker?
November 4, Uniform Victor Charlie.
Got it. And 4, you say? I get a copy. This is Echo Alpha 3, Charlie. Name is Frank. I'm in Barcelona. Not the city, but 15 miles north. I give you a 5 and 6 to 7.
So, as you can tell, the bands are starting to get hotter again. This is 15 meters single sideband. It's because the sunspot cycle has come around, and we're starting to get some excellent skip conditions at the higher frequencies. This is the highest band, 15 megahertz WWV. So an Italian station coming in on 15 meters, upper sideband. So what got me 15 meters back was spraying the band switch with contact cleaner. And I tell you, these contacts just can't be too clean when you get to this high frequency. It's still drifting around a little bit. There is some backlash up here at this highest band, but it does work. It does pick up sideband on 15 meters. So this is 10 meters, the very, very, very top of the frequency band. It is actually open a little bit. Whoop. Wow, CW signal on 10 meters. Let's look at its single signal selectivity for CW. Going through 0 beat. Not quite. Okay, so I'm biasing a little higher in frequency, lower sideband. Basically, I move the filter over a little bit. That's not perfect single signal selectivity, but for a novice, this would have been a good receiver. This is doing very well on 40 meters. Here we are up at 7.1 megahertz. A lot of people do slow CW up here now. On 40 meters, there's two different settings. You set this B2 when you're going to do the upper part of the band for a sideband on 40, and you do the B1 that gives you the lower part of the band for CW. I like what they've done there with the band spread, giving you two different 40 meter bands. That would have been really good for a novice. The AGC is excellent on this receiver. It's a beautiful compromise. You can just see how it's fast attack, slow decay is good for CW as well as single sideband. S meter working very nicely. Demonstrating the AM automatic noise limiter. As you can see, it does not affect the signal too much. Okay, we're up on the CB band. I knew we'd get there eventually. So I think we have a Dream receiver back on the air, and a few things discovered along the way. The alignment, we had a little anomaly with me putting the local oscillator on the wrong side of the carrier. I contacted the original technician that worked on the radio and put it back into working order way back in the 70s. And now I have the whole backstory on the receiver. So we've got one more little video that I'll do on the receiver. I'll give you that backstory, And maybe we'll hook up a couple of receiver, I'll call them adjuncts. The receiver did come with a Q multiplier. Might be nice to make that work with receiver. And also I will demonstrate a crystal controlled converter for 15 meters with the receiver. These are very common items that were put in front of these receivers back in the 70s, late 60s, early 70s.